Hello, beautiful people of planet Earth. You're watching this recording for my second version of my presentation for Symbionics, a theoretical summary of ecobionics or symbiote mimicry by Nathaniel M. Zapplater. So let's go. A brief explanation of Symbionics. Before I begin providing examples based on design concepts, I will provide a summary of the meaning and purpose of Symbionics. The term Symbionics is derived from the root words symbiosis and bionics. The why or objective of Symbionics. The scientific objective of Symbionics or symbiotic engineering would be to translate the ecosystem relationships, services, processes, and functions of varying examples of biological symbiosis into architectural, urban, agricultural, industrial design to regenerate local ecosystems and biodiversity, as well as provide for human needs. It is meant to be an extension of biomimicry and regenerative urban design. Simply put, it is my theory based on considerable research that the same principles underlying biomedical or bionic engineering can be applied to biomimetic and urban ecosystems design. Excuse me. For more detailed scientific and engineering explanation, here's the link to my previous lecture video. I go into a lot more detail about every level of how each of my invention concepts provided in this lecture work and how they would be powered and as well as manufactured and its life cycles. At the right-hand side is a visual representation. Symbiosis plus bionics equals symbionics. This is an AI-generated concept of my symbiotic invention called the Lovelock tree. I will get into detail about that next slide. It's just an AI illustration to help you understand visually kind of what I'm going for. It's not meant to be a definitive or even general blueprint or schematic for the real thing. So let's continue. Symbionics, examples in design fictions 1. The Lovelock tree network. The Lovelock tree or Lovelock tree network, named after biologist James Lovelock, who created the Gaia hypothesis, it is meant to be an energy distribution and ecological restoration device and eco-industrial infrastructure. It is also designed to be a multi-energy input system powered by artificial photosynthesis, natural photosynthesis, gyroscopic wind power, and hydrogeothermal energy. Functions integrate with and regenerate local ecosystems, distribute energy and power the built human environment, provide habitat for tree-dwelling animals, serve as a medium between the human-built environment and the natural environment, provide a more accurate biomonitoring and sensory capabilities, regenerate or put back whatever biomass we extract from ecosystems. This can be achieved by taking whatever biomass whatever biomass in the form of waste, whether human or domestic animal waste, or dead animal carcasses, or dead plants, and putting them back in through the system to be filtered and to be purified and put back into the biomass. So on the left-hand side, you see a picture of my first hand-drawn illustration. At the top are bionic leaves powered by artificial photosynthesis. Since then, I've added a biophilic layer made out of bark and organic polymer to allow for a natural photosynthesis. At the bottom, you see hydrogeothermal energy represented in the two water tanks, one cold, one hot, representing thermal diffusion. At the top, you see gyroscopic wind generator. The reason I went through a gyroscopic design over a traditional wind turbine was that, in short, wind turbines create sonic pressure waves that are harmful to animals and insects that inhabit most forests and rainforests. So let's continue. Symbionics, examples, design fiction 2. The Trident Ocean Guard hive mind. The Trident Ocean Guard hive mind is a theoretical design for an aquatic, ecologically regenerative, or restorative swarm of soft robotic drones meant to repair the ocean's delicate ecosystems like those of primarily coral reefs, as well as contribute to the deacidification, carbon dioxide buildup of the oceans in large bodies of water, including rivers, lakes, ponds, swamps, marshes, and aqueducts, and even other forms of groundwater, etc. capable of interconnected coordinated action via artificial intelligence, artificial life software, and human guidance. Constructed primarily from biopolymers, conductive nanofiller biopolymers, biodegradable plastics, recycled and upcycled electronic components to reduce electronic waste. This is done by a process called industrial symbiosis, which if I had, would go into more detail. But basically, it's a form of industrial recycling employed in countries like Sweden and South Korea, who have achieved a high degree and have eliminated almost all of industrial electronic waste. In fact, Norway has imported their electronic waste to Sweden to help them reduce their electronic waste. Um, repair methods and life cycle. Ideally, once the soft robotic aquatic drones are beyond repair, a boat-faring team of engineers or diving engineers could strip all of the non-biodegradable components from the drones to reuse them for later, industrial symbiosis, then allow them to fall to the seafloor and biodegrade to use for material for natural aquatic habitats. That's why I have emphasis on soft robotic components, because they rely a lot less on heavy metals, which are toxic. So let's continue. Symbionics example in Design Fiction 3. I apologize, I am trying to come up with a shorter name for this invention concept, but I haven't thought of it yet. Hothouse Earth Subterranean Open System Biodome Terraforming Arc Infrastructure. In case of hothouse Earth on the surface, please break open. This is for all you eco defeatist doomers out there who are doing nothing to save the environment. So I've already anticipated the arguments of eco doomers who say it's too late to save the planet. And so I came up with this design. So a hothouse Earth subterranean open system biodome terraforming arc infrastructure is a highly theoretical and speculative way to combat runaway climate change and global warming. Designed to evacuate as much biodiversity, i.e. plants, mycelium and fungi, animals, microorganisms, and humans as possible, in order to create pockets of macro and micro biospheres like those found on Earth's surface. Inspired by underground skyscrapers like those found in Mexico City, theoretical designs for lava tube bases on the moon developed by NASA, and the theory of subterranean or deep biospheres, which have already been found deep within hydrogeothermal vents underneath the ocean, as well as in the Earth's crust. And it's speculated among astrobiologists that there are deep biospheres potentially in Mars, where the last remaining life forms escaped once Mars's atmosphere was stripped off, as well as potentially Venus before the atmospheric pressure got too much for land-dwelling life to survive, as well as the superacidification of Venus, and obviously the ice shell moons of Ganymede, Europa, and Callisto would also count technically as deep biospheres because they are speculated to exist deep within the layers of ice. And there's a lot of evidence, especially for Ganymede, that such a deep biosphere actually exists, and for Europa. So its function would be to create surface biosphere-like conditions only underground, in subterranean or underground pockets, so that we can re-terraform Earth back into its pre-hothouse conditions once time is right, restoring as much flora and fauna as possible when conditions are right to begin re-inhabiting the surface when a stable enough subterranean biosphere is created. So I'm going to go into more detail on the next slide. Here you see a visual representation of a hydrogeothermal vent deep biosphere. Jules Verne's Journey to the Center of the Earth, written sometime in the 1800s, is actually an example of a deep biosphere before the theory was even created. At the top right-hand corner, you see two representations of the underground building in Mexico City. I think it's already under construction, or it's almost completed construction, if I'm not mistaken. At the top right-hand corner, you'll see how there are large holes allowing for sunlight because it is necessary. At the bottom, you see NASA's concept for exploring underground dead lava tubes that are no longer active in the moon for bases so that astronauts can escape deadly UV radiation because there's no atmosphere on the moon. So let's go on into more detail. So, basic design strategy. As shown in the underground skyscraper concept in Mexico City in the previous slide, on the the top left hand corner, filtered sunlight and UV rays could be brought down deep into the subterranean terraforming infrastructure because it is necessary for all animals, plants, and humans to survive. Air filters could be attached to the light wells to filter out any toxic carbon dioxide and methane. Those same proposed light and air wells could also be utilized in reverse to pump or transfer more purified air back to the surface, as well as utilizing carbon sequestration of various kinds, be it natural or artificial, or both, to reverse the damage done to the biosphere and thus the surface of the earth, as well as the oceans and other large bodies of water. Admittedly, this design fiction is highly speculative and in its highly theoretical stage, unlike the other two examples, which have more immediate potential to develop functional prototypes and immediate experimentation. I have also thought of ways of recently trying to design an artificial sun for such an infrastructure if light wells with light filters cannot be incorporated or practically realized. Here are some AI generated images that a friend of mine named Jacob, generated for me as a visual aid in the next slide. So again, this is not meant to be a definitive schematic or blueprint. This is just to help you understand kind of what I'm going for here. But on the on the left-hand corner, these two images right here are actually very close to what I'm kind of going for, because in both instances and in the top right-hand corner, you can see sunlight being filtered through and coming deep underground, as well as at the bottom right-hand corner, you even see small bodies of water, which is what would need to be generated underground as well. So let's continue. Symbionics example design fiction 4. Eco-industrial interface rapid retrofitting cellular membranes. So before I begin, I just wanted to say that the subterranean ecodome biosphere terraforming infrastructure is not meant to be my main strategy. It's just for a worst case scenario climate change scenario. A worst case scenario for climate change. But that's not what I'm banking on. So in its simplest terms, an eco-industrial interface and rapid retrofitting cellular membranes are conceptually designed as surface areas made from biopolymers and other biomaterials, perhaps partially sealed to allow for breathing holes for oxygen and airflow, with some type of glass that would be attached to any current existing building and industrial service to allow for the attachment or growth of organic materials, be it plant or animal, without damaging the structural integrity of the mechanical, architectural, or energy systems. This could theoretically allow for a much quicker greenery or biophilic redesign of cities and other urban infrastructures and energy systems without having to redesign them completely from scratch. Its primary function would be to allow for the exchange of organic materials and fluids between artificial and living systems, to allow for more effective biosensor and ecological data collection. So this would also allow us to help us also better monitor our progress on how well the environment is responding to how my designs are potentially regenerating the health of the ecosystems, be it on land or in water. This, at the bottom right-hand corner is a representation of an artificial cell and a basic representation of a natural cellular membrane and a artificial cellular membrane. Artificial cells and cell membranes are already in development and show great promise. Many of them are actually made out of biopolymers and eco-friendly materials because they need to allow for the seamless transfusion of materials the way cells do. And at the left-hand corner are AI-generated concepts for visual aid. Actually, the top and the bottom are both pretty close to what I would kind of go for, but they don't look exactly like as I imagined. But again, just visual aids to help you understand. Let's continue. Oh, sorry. It's primary. Yeah, I already said that. So let's continue. So finally, symbionics and symbiote mimicry. Best possible avenues for paths for experimentation. There are many ideal environments and spaces to carry out physical experimentation on many of my invention concepts outlined in this presentation. Many of them include, but are not limited to, greenhouses, forest clearings to test the regenerative capability, specifically of the Lovelar tree network, or augmented or attached to a tree stub itself, an isolated or enclosed small patch of forest, uh, an enclosed small aquatic or semi-aquatic environment. I'm sorry, for aquatic or semi-aquatic experimentation, a small body of isolated water. Proposed designs for ecological laboratories like those industrial parks found in South Korea, and this one here being proposed in Chicago. This is called the Eco Laboratory in this is called the Eco Laboratory in Seattle, Washington, not Chicago. Completely different U.S. state. And this is a representation of an illustration called Symbiote World by Jimmy P. Dula, which kind of is an artistic representation which is close for what I'm going for. A complete ecological industrial redesign of civilization itself. Thank you and have a great night. Bye.